Hello, welcome to my presentation on Module 3 on Algebra. It is a Python AI developer course. Now here, in this presentation, we want to automate problem solving in Algebra by using Python as the programming language. Now in this specific example in Module 3, we will try to solve systems of linear equations using substitution and elimination. Now, what is essentially substitution and elimination? For as far as I could recall, the substitution method will involve solving for one variable in terms of the other, and then we substitute it into the other equation. Now there is a general step that is quite involved in a substitution method. Now we try to solve one equation for one variable in terms of the other, and then we substitute this expression into the other equation, and then we solve for the remaining variable, and then we substitute it back to find the other variable. Now, for elimination method, well, it involves adding or subtracting equations to eliminate one variable. Well, the steps involved here is generally we multiply one or both of them, both of the equation, so that one variable has the same coefficient in both of the equations, and then now that they have the same coefficient in both equations, we can add or subtract the equations to eliminate one variable, and then we solve for the remaining variable, and then we substitute back to the other, we substitute it back to find the other variable. Now, in order to demonstrate all of those steps, let's try to automate the whole process in order for us to see or visualize the entire process of solving through substitution and elimination. And of course, let me try to give an additional feature of the program such that it will provide a graphical representation of the system of equations. Now all we need to do is to copy everything here and paste it to a AI. Now the AI of choice here is DeepSeek. Now I have done that, and DeepSeek has generated for us a code, and all we need to do is to copy and paste it to IntelliJ, and I have done that, and I have created a file here called system of equations.py. py is the extension for Python, and I have pasted all of the Python codes here. Now before we try to analyze it line by line, if you are not familiar yet with Python programming, then there's no problem. I have a video for this Python. It's essentially an introductory course to Python programming. All you need to do is to go to YouTube and type my name, Michael Mananghaya, and you will see a Python AI developer course. Now it entails all of the essentials for Python programming, such as the introduction. We have a flow control, we have a list. I have also discussed about dictionaries, keys and values. Now of course functions is very important, so we have a separate video for functions, also for utilizing APIs, and finally a course for inheritance. Okay, so you might as well watch those videos before you go here. But if you have a working knowledge about Python, all you need to do is to follow the code here, and I will paste the corresponding code in the comment section so that you can replicate every output from the program. Now let's try to go back to the program, and let's try to analyze it line by line. Now here we import necessary libraries for random number generation, plotting, and latex. Now import random for generating random numbers. We have matplotlib.pyplot as a PLT for plotting, and etc. We have these other libraries. Now don't forget to have a mctex path you must download the Mictex program, and you only to for you to download the Mictex, as I have said in my previous videos, you have to go here to mixtex.org, download. You have to download the file, and don't worry, everything will run smoothly. You find no difficulty in installing the program. You just have to be patient because the program is quite relatively large. It takes a couple of gigabytes, and after that, might as well install also GoScript from GoScript.com. Now, if everything there is installed, then you have to specify your path. My path here is Mixtex bin x64. More or less, you will have the same path, the OS environment. So you have to specify the path. Now, of course, you have to set the matplotlib RC params use text to true, so that you have a rendering in matplotlib, so we can see the mathematical expressions in human readable form. Now, let's try to go here. We have several functions here. We have functions to generate the system of equations, and also we have a function here to generate some hints. We have a function to show the substitution, because we're solving an algebraic expression or algebraic systems of algebraic or linear systems of algebraic expressions. We need to show the substitution steps, and of course a variant, which is the elimination steps. Of course, we need to visualize the system. We have the plot system, the function plot system. We also have the main function. Now let's try to go to the main function. Now in the main function, hey, welcome to the system of equations scavenger hunt. You have to print that, and then there's a line there that you are trapped in a virtual room. Solve each system of equation to find the next clue. So if we run everything, so we have here, it will generate this step-by-step solution, this beautifully written in latex, and as you can see, everything here is human readable, and the equation are written in a well organized manner. But all we need to do now is to follow the steps. Now here, this is a substitution method, so might as well, yes, he is calling the step-by-step solution using substitution and elimination. The first one is substitution steps using latex, and the other is elimination steps. So the first one that we see is substitution, and we try to go there, the substitution method. Let's try to explore that. We have the substitution. Show the substitution. Okay, here. So show the substitution steps in latex. So it has these parameters. Now, in the first line, we start with the system of equations. So that's step 1, and you can see it here, where we advertise system 0 and system 1. So you have these two systems of equation. Now we solve equation 1 for x. Solve equation 1 for x. Now how do we do that? Well, all we need to do is, well, of course, the solution to that is just C1, and then you transpose the B1y in the other side and divide it by the coefficient of x, which is A1 in this case. And we see that. So all we need to do is to transpose 5y in the other side and divide it by the coefficient of x, which is 1. Well, we have this, and then we substitute the x into the equation 2. So that is essentially this x, and then we substitute it back in the second equation. So 2 multiplied by x plus 2y equals 3. Do we see that in the code? Substitute x into equation 2. Yes. And here, all we need to do is yeah, essentially we have substituted this one. We have c1 minus b1y divided by a1, and then we multiply it by a2. So a2 here is 2 plus b2y. So b2 here is 2, and of course we have c2. The c2 here is 3, and then we simplify and solve for y. Okay, so here we have c dot. That's the reason we see a dot here for the 2 and the 3, and a dot for 2 and 5. So c dot, c1 and a1 minus, so we see a minus here. Well, c dot again, b1, a1. Okay, so we just essentially multiply this coefficient 2 to the numerator, 3 minus 5y. So we get this plus 2y. So plus b2y equals c2. So equals 3. And then we can try to proceed there, and then we have the solution, y solution, which is 0.375. Okay, so what he did here is he grouped this term, and then this 2 multiplied by 3, he transposed it to the other side. So do we see that? Yes, c2 minus c1 e1. So this term here, and then we have the solution now, which is 0.375, and then we try to substitute it, the y back into equation 1 to find x. So we have the last step, substitute y back into equation 1 to find x. So that's 3 minus y solution. So we have the y solution here. The y solution is 0.375 divided by a1, and then x is 1.125. So that's it. He presented it in in a very organized way and human readable. So all we need to do now is to go to the elimination steps. If we close that, of course we call on the elimination steps now. So we wait for a while. Okay, so elimination steps is loaded. So let's try to analyze it from the Python code. So we start here. The steps is start with the systems of equation. So start with the system of equation, and might as well display system 0 and system 1. So these two systems of, so these are two linear equations. So they form the system of equation. So it's essentially system 0 and system 1. Now we multiply equation 1 by a2 and equation 2 by a1. So let's try to do that. So multiply equation 1 by a2. Now the a2 there is 2. So 2 multiplied by 1, you get by 2, and then 2 multiplied by 5, you get 10, and 3 multiplied by 2, you get 6. So that's essentially this. So we have this, multiply 1 by a2. So a1 multiplied by a2, b1 multiplied by a2, c1 multiplied by a2. And the same thing goes to the other equation. All we need to do is multiply the second equation by a1. So we see a1's here. So we go on to the next step, which is subtract the equations to eliminate x. Now that this the coefficients for x is the same, might as well subtract it so that we can cancel the variable x, and we have 10 minus 2y. So do we see that here? Yes, this b1 a2 minus b2 a1y. So we have that, and we have this value in the right side, c1 a2 minus c2 a1. So we have now the y solution. Now that you have the y solution, we substitute y back into equation 1, substitute y back into equation 1 to find x, and then we have the x solution. Okay, so what will happen if we close that? In the main program, after we presented the substitution steps in latex and elimination steps in latex. All we need to do is to plot the system. So we expect a plot now. Let's try to see if there's a plot. So again, we try to wait. Oh, okay, so everything is loaded and it's working fine. So let's try to see the plot system. So in the plot system, the coordinate for x starts with -10 and 10, and that's correct, -10 to 10. And we have the well, okay, so we have the plots here, and we have the corresponding label. For equation 1, we have a1x plus b1y and c1, so we have it here. Line here, that's the blue line. Now the other one, okay, so we have a2 plus b2, a2x plus b2y and c2. Okay, so we have this, and we also have the solution. So we have the line 2x plus 2y equals 3. So we also have the solution. The solution is represented here to be the intersection of the two lines. So we highlight the solution point, and the color here is red. So do we see the red? Yes, it's a red dot, and we label that as the solution. Okay, so the x solution and the y solution, so we point it here. So it's the solution is 1 and point 0.3. So as you can see in the lower right portion of my plot, so essentially 1 and 0.3. Okay, so we have the x and the y label. We have to plot the legend, and we set the grid to true. As you can see, there are grids here, and then we have the title graph of the systems of equation, and then we try to show everything. So we have it here, and then if you close it, now is the time for us to enter the value of x and the okay, so enter the value of x and enter the value of y. Assuming we have not made the correct solution, let's try to have a random solution. Say for example 1 and 2. Okay, so he will say the solution was 1 and 0.3, as we have seen in the previous solutions. That's indeed 1.1 and 0.3. So he will show the correct solution. So where's that? So sorry, the correct solution was, of course, your x solution and your y solution, and then you've escaped the virtual room. So you've escaped the virtual room, and then what will happen now if we input the correct answer? So let's try to run again the program. So again, we generate substitution method first. We call a substitution method, and we take note of the answer for the question. We wait for a while, so it's generating. I hope it works. So my apologies, my PC is relatively slow. So we try to wait for a while. Okay, so the step-by-step solution, the substitution method. Now here, the system of equation is 5x plus 5y equals 2, and 5x plus 3y equals 8. And take note of the solution. The solution is -3 and 3.4. So let's try to put that in the x and the y. 3.4 and 3. So again, we generate another file for the elimination method this time. Okay, so take note of the solution. The solution is again negative 3.4 for x and negative 3 for y. And then we close that, and of course it calls on now on the plot so that we can visualize everything. By the way, in the plot we can see the intersection and the solution here. So again, the solution for the problem is 3.4 and negative 3, so that's essentially correct. So if you see in the lower right portion, that's approximately 3.33 and negative 3.15, which is relatively close to the true answer, which is 3.4 and negative 3. Okay, so we have to input the correct answer now, so we try to see that. Okay, there's a tolerance here of 0.01, so you can adjust that if you want a higher tolerance. So if the your input answer for the value of x is relatively close to the solution, say for example, let's try to revise it, just make it 0.1. But everything here, well, in solving algebraic problems, the solution matters. So even if that's just a 0.1, well, I think this is a good value, since if your answer is relatively close to that, the system will consider that to be correct. So let's try to see. So let's try to input the correct value 3.4, and then for the value of y, negative 3. So what happened? Okay, so correct. So our answer is correct as expected, because we input the exact value. So correct. Here's your next clue. So you will try to go on to the next clue, and then we generate the hint. We go on to the generate hint. Let's try to take a look at the general hint function. In the general hint function, well, let's try to take a look at the general hint. Okay, so here's a general hint. We have hints here. So look on page number 3 of the math textbook. Okay, so here, look on the page where the page number is 3 of the math textbook. You can tailor it to have hints that will be applicable to your classroom settings. Now, these hints are rendered, well, they are generated in random. So we have a random choice hints. So for this example, he chose the third one. Look on page number 3 of the math textbook. Now, after that, he will generate another clue number 2, solve the following systems of equation. Then that's it. The student could, or the user of this could proceed with the other problems, and after a while he will be familiar with the process of solving systems of equation. After a few tries, say for example after doing 10 clues or 10 systems of equation, he will be already proficient in solving systems of equation through substitution and elimination. Now here, I have successfully shown to you that algebra could be automated, specifically systems of equation that's solved through substitution and elimination. So we show the steps in a human readable form in LaTeX. We show the substitution steps in LaTeX, and we show the elimination steps in LaTeX also. Both are human readable form, and it's well organized, since the DeepSeek AI model have generated it has generated a code that is quite step by step, and all of the essentials of the solutions pertaining to substitution and elimination was demonstrated. And we can see also a plot of the linear systems and its solution, the intersection point, and with the corresponding legends. And I think that's all. In the next videos, we will discuss more on how to automate algebraic solutions. So let's try to see the next topic, as generated by DeepSeek model. So we go on to the fourth module, which is polynomials, higher order. So we explore factoring, and then power of 2 quadratic equations by factoring, and an introduction to quadratic formula. But for now, it's quite lengthy. It's already 26 minutes. So I'll see you in the next video. For now, that's all, and thank you.